I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me for this video where we are looking here at a differential equation, second order, non-homogeneous, having to do with damped forced vibrations. We're not specifically talking about what this is because that is beyond the scope of this video, but this differential equation would describe the motion of a body which is undergoing this specific type of vibration, which is called a damped forced vibration. In this type of vibration, an object is undergoing a vibration. There's a force being applied to the system to resist movement of that body. However, it is still driven by periodic application of force. You can Google this and research this for yourself, but for an object which is undergoing damped force vibrations, you could see an equation such as this with boundary items such as those, and then you would have to solve it out and determine what is the solution of this differential equation. You have here a second order derivative with respect to x and t, d square x over dt square plus 5 dx over dt plus 6x is equal to cosine t. Your boundary items which you will use to convert your general solution into a specific solution are at time t equals 0, you have x equals 1 over 10. At time t equals 0, you have a first order derivative value equal to is 0. Your variables are x's and t's. Time here, t would be your independent variable, x here is your dependent variable. We will use our techniques to arrive at a general solution. We will use those boundary items to arrive at a particular solution. Look right over here at this part and we will determine our complementary function first. You would bring those items into play. And this right here is your second order derivative. You would have r squared e to the rt plus 5r e to the rt plus 6 e to the rt, and you equal it to 0. When you're doing your complementary function determination, you're using your homogeneous techniques. You treat your equation as if it's homogeneous, it's equal to 0. But here your function is not a 0, it's a trigonometric, hence overall it's a non-homogeneous equation. Solve it out. Isolate the exponentials, take them on the other side, they zero out. What you are left here with is r squared plus 5r plus 6 is equal to 0, and then you have factors r plus 3 and r plus 2 is equal to 0, and r is equal to minus 3 comma minus 2, or you can say minus 2 comma minus 3. Either way it's fine. It leads you to your complementary function. I'll put it for you right here. X here is equal to a constant e exponent minus 3t plus another constant b e exponent minus 2t. Again, our variables are x's and t's. You could have even said you have x is equal to a e exponent minus 2t plus b e exponent minus 3t, because it depends on which of these orders you picked, minus 3 minus 2 or minus 2 minus 3. Either of those is still perfectly fine. Complementary function has been determined. You can pick either of these. Let's do our particular integral. When you have something which looks like this, your template for a trigonometrics, x is equal to c cosine t plus d sine t. The first order derivative is what? Minus c sine t. And then here you'll have a plus d cosine t. Your second order derivative is going to be a minus c cosine t minus d sine t. What do you do with these items? You plug them right here in places of your second order, your first order, and your zero order. You put your second order, you have a minus c cosine t minus d sine t plus 5 times your first order, you'll have a minus 5c sine t plus 5d cosine t, 6x all of this, plus 6c cosine t, and then plus 6d sine t. When I'm looking at my sine t terms, what are they? I have a minus d, I have here a minus 5c and a plus 6d. Minus d plus 6d is a 5d and a minus 5c. I have a minus 5c plus 5d. That's what I have, and you can look at it again. My sine terms are a minus d and a plus 6d, which is a 5d, and I have a minus 5c. My cosine t terms are what? I have a minus c, a plus 6c, which is here a 5c. Then I have here a 5d, cosine t, a 5d, plus 5d. Here are my systems of linear equations. I'm erasing everything from here which we don't need anymore. I'm keeping this because this maintains our template for our particular integral right here. When we determine the values of c and d, we'll plug them into this template right here. Look at my systems of linear equations. For the sine, I have a minus 5c plus 5d equaling is 0 because there's no corresponding term here. For the cosine, I have a 5c plus 5d is equal to your value 1. Before we proceed any further, look right here at this template. I have here c cosine t plus d sine t, and here I have a cosine t. This right here is my function right over here, my function f of x. But this could have been very much a cosine 2t, in which case then here you're being 2's and 2's. Here I'm looking at a constant, particularly right here associated with t. My k value here is equal to 1, hence I have a cosine 1t sine 1t, which feeds through. You don't need to write 1, it's assumed to be a 1, but the k values can change based on what it is, and then that constant, the k constant, affects the period of the system. Here the period has a k constant value of 1. Look over here, elimination technique. Add them up, this goes, you have a 10d is equal to 1 and d is equal to 1 over 10. Put everything into this equation right here. I have a minus 5c plus 5 over 10, which is a 1 over 2 is equal to 0. Solve for c. Minus 1 over 2 divided by minus 5 is a 1 over 10. My c is equal to d, which is equal to 1 over 10. And that's solved. We have everything coming here into this template. We know c is equal to d, which is equal to 1 over 10. Let's bring them in. My particular integral will be x is equal to 1 over 10 cosine t plus 1 over 10 sine t, because c and d are 1 over 10. Now we have to post our general solution. Our general solution is going to be x is equal to, pick one of these. It doesn't matter, I'll pick the top one. A e exponent minus 3t plus b e exponent minus 2t plus, look right over here, add your particular integral, but I'm going to isolate the 1 over 10, and then I'll just do cosine t plus sine t. Nothing wrong with isolating here and then writing it this way. Here's my general solution. You don't need to see this anymore because we have our particular integral already posted in our general solution. Complementary function, my particular integral. Now let's look at those boundary values. We know at time t equals 0, x is equal to 1 over 10. This is your basic zero order function, your original function for which the top values will apply. At time t is equal to 0, x is equal to 1 over 10, which means this right here is equal to 1 over 10. You have 1 over 10. You know what? I'll put it right here on the top. I have 1 over 10 is equal to, at time t equals 0, wherever you have t's, put 0. E exponent 0 is a 1. You just have an a, because e to the power of 0 is equal to 1. Here e to the power of 0 is equal to 1. You'll just have a b. Cosine of a 0 is a 1. Sine of a 0 is a 0. But I'll have a 1 over 10. I'll have cosine of 0, which is a 1, plus sine of a 0, because in places of t's I'm putting zeros. I have that. What do I have? I have a plus b is equal to, push this 1 over 10 on the other side, it's 0. I know here a is equal to minus b. So let's put this aside and we have this so far. Now come over here. At the second values, at time t equals 0, our first order derivative is equal to 0. I take a derivative of this statement. If x is equal to all of this, what's the derivative of that? We'll do the derivative of this. You'll have here a minus 3a e exponent minus 3t minus 2b e exponent minus 2t. Do the derivative of this. You can separate them out if you want, or you don't have to, and you keep everything as is. 1 over 10 stays as is. The derivative of cosine t is the minus sine t. Derivative of this is the cosine t. It flips around. You have a cosine t minus sine t. This right here is my first order derivative. In this first order derivative, we use these second values, your second items. At time t equals 0, it's equal to 0. So we bring that into play. You see when I'm looking right here on the top right here, I'm erasing a few items because I need space. I have a plus b is equal to 0 from here, and I know a is equal to minus b. I'm saving this and I'm erasing this because I'm going to work on this second set of boundary values, which are right here in the box item. My first order derivative is equal to 0 when time is equal to 0. In all these variables, t put a 0. You again will have e exponent zeros, which are equal to 1. You'll have a minus 3a. Here you'll have a minus 2b, because again these exponents will be zeros. E to the power of zeros are 1, plus 1 over 10. Cosine of a 0, you know what that is. That's a 1. Sine of 0 is a 0. You'll have a 1. So this is what we have. You take this 1 over 10, you push this on the other side. What will you get? You'll have here a minus 1 over 10. And then you can eliminate this because I've pushed this on the other side. I have minus 1 over 10 is equal to minus 3a minus 2b. But if you hit everything with a minus, you can change everything to a positive. I have two items here now. A plus b equals 0. and I know here 3a plus 2b is equal to 1 over 10. Here are my systems of linear equations. You can do this the hard way or you can do it the easy way. If you know a is equal to minus b, you can just run that through. There's nothing wrong with that. So we have this, let's work it out. I'll multiply everything here with the minus 2. I'll have a minus 2a minus 2b is equal to 0, and then 3a plus 2b is equal to 1 over 10. Let's add them out. When I do this, and you could have done this the easier way, the shorter way, but I don't want anyone saying I was skipping around steps or taking shortcuts. You could have ran this through and it would still be the same. I have over here, adding up elimination technique, a is equal to 1 over 10. If a is equal to 1 over 10, then a is the negation of b, then you know b here is equal to minus 1 over 10. Think about this statement right here. If a is equal to 1 over 10, b is the opposite of that, it's minus 1 over 10. That's what it is. We have everything we need now, because the whole purpose of using these boundary values were to get these constants, and we've determined them. We don't even need this statement here anymore because it has served its purpose by means of giving us the values of a and b. You plug in these values here in places of a and b and you will have your solution to this differential equation using those boundary values. What is our solution? Our solution here is x. You can even say x with respect to t is equal to whatever. You can say that, and there's nothing wrong with saying that. A is equal to 1 over 10. 1 over 10 e exponent minus 3t. You have a minus 1 over 10 e exponent minus 2t, then plus 1 over 10. You have a cosine t plus sine t. Here's our solution. But if you want to be even more fancy, you can. Because you are seeing 1 over 10s all the way across, you can isolate a 1 over 10. And I want to do that. I'm erasing this because you know a is equal to 1 over 10, b is equal to minus 1 over 10. We'll use algebra over here and post our answer in a better way. My solution can be this: x with respect to time is equal to 1 over 10 has been isolated. And now I have e exponent minus 3t minus e exponent minus 2t. Then I have a plus cosine t plus sine t, and here is my answer, and it should be correct. So in all of this clutter over here, let's identify what our solution is right here. In the best format is this: x with respect to time, or just say x is equal to 1 over 10 parentheses e exponent minus 3t minus e exponent minus 2t plus cosine t plus sine t, close your parentheses, and you're done. You can post that, or you can post this where you have not isolated the 1 over 10s. Either way is fine. That's it for this video. Thank you for watching.